Hi, I'm Zhenyu Jiang. I'm glad to present our work, Ditto, Building Digital Twins of Articulated Objects from Interaction. Virtualizing the physical world can unlock new research and applications in multiple areas. For example, we can spawn the virtual objects in mixed reality and interact with them. The virtual world can also facilitate robot learning by providing a realistic environment in physical simulation. Virtualizing the physical world can be an integral part in building better AI systems. To benefit from virtual data, realism is the key, because realistic virtual data bridge the virtual and the real world. Digital twin comes into play when we need to create realistic virtual data. Digital twin is a living virtual representation of something physical. It accurately reflects its physical counterparts, therefore can narrow the gap between the virtual and the real world. Currently, most digital twins are created manually and require a lot of human labor. One automated way of creating digital twin of physical objects is 3D reconstruction. The best 3D scanner nowadays can precisely build digital twins of static rigid objects. In addition to rigid objects, many objects in real scenario are articulated, such as laptop, cabinets, and faucets. They consist of multiple parts connected with different types of joints. To enable interaction with articulated objects in the virtual world, we need to build interactive digital twins. Building interactive digital twins of articulated objects is particularly challenging because it requires recreating both the geometry and articulation of the object. Unlike 3D geometry reconstruction, estimating articulation from static observations is inherently ambiguous. For example, these two dishwashers share similar appearance, but their articulation models are very different. To correctly estimate articulation, we need to interact with these objects to create novel observations. In this project, our goal is to build digital twin of articulated objects from interaction. Given the observations of objects before and after interaction, our model Ditto simultaneously reconstructs part-level mesh and articulation model of the object. Ditto consists of a two-stream encoder and multiple implicit decoders. The encoder fuses a pair of input observations into feature grid and planes. The decoders decode the geometry and articulation. Our encoder takes as input the point cloud observation before and after interaction. To fuse the two observations, we first encode the point cloud into sparser point features. Then we compute dense attention between two sets of features. Computing attention on subsampled point features greatly reduces the computation costs. After fusing the point features, we use a decoder to upsample the sparse feature into dense point features. Dense point features preserve more details. We use two separate decoders to produce dense features for geometry and articulation prediction. The geometry point features are pulled into 3D feature grids. The articulation features are projected and pulled into 2D feature planes because articulation estimation does not require very dense reasoning. Then we use implicit decoders to query per point occupancy and segmentation, as well as per point joint parameters. During inference, we use Martian cube to extract part-level mesh and use joint voting to estimate the global joint parameters. Here are some results on test set objects of our simulated dataset. Ditto is able to faithfully reconstruct the part-level mesh and articulation model of these objects. We also test Ditto on physical objects. We interact with this small cabinet with hand and collect multi-view observation before and after interaction. Trained with simulated data, Ditto can generalize to real-world observations and create the digital twin of physical articulated objects. Here we demonstrate one interesting application of Ditto. We recreate the digital twin of this faucet and spawn it in RoboSuite, a physical simulator. Then we manipulate the faucet in the simulation. After calibrating the simulation with the real world, we can directly transfer the action in simulation to the real world. With Ditto, we can transfer from real object to simulation and transfer physical interactions back. In conclusion, we use embodied interactions to create novel observations of articulated objects. Ditto encodes these observations into grid-based implicit representation and build the digital twin that bridges the virtual and the real world. Our code and model are available at the website at the bottom right corner. Thank you.